Okay, so we are finishing up this guided note packet that we did not finish in class. So we sorted off all the rational and irrational numbers into buckets, right? All right, so now for number 2, for each number listed above in the rational square or rational circle, classify it as either natural, whole, or integer. So I've got our definitions here for each of those. Natural is a positive counting number starting at 1. Whole is a positive counting number starting at 0. And integer just means no decimals. It can be negative or positive. So we can definitely be one or more definitions. So we could be a natural number and a whole number, or a natural number, a whole number, and an integer. Now, these are only for the rational numbers, right? Irrational numbers can never be any of these three things. So we're only looking at the rational. So I'm going to go ahead and pause the video and list out all the rational numbers above so that we can go ahead and classify them. So I wrote out all of the numbers. Now I am ready to classify them. So we'll always start off with natural, because if something is natural, then it's also the other two. All right, so looking at this, is 0.8 a natural number? Is it a positive counting number starting at 1? No, it's not. Let's go to our next one. Is it a whole number? Is it a positive counting number starting at 0? No, it's not. All right. Is it an integer where it's no decimals? No, it's a decimal. So the only definition it meets is rational. That's it. It's only rational. It's not anything else. All right, let's go ahead and try number 2. We might need to simplify things before we classify. So we know that square root of 64 is a rational number because it's a perfect square radical. So the square root of 64 is 8. So let's use 8 to classify it. And again, we'll start with the most restrictive definition, because if it meets natural numbers, that means it's everything else, right? So is this a positive counting number starting at 1? Yes. 8 is a counting number, right? 1, 2, 3, 4, 5, 6, 7, 8. So it is natural. If it's natural, that means it meets all the other definitions, right? If it's natural, it's also a whole number because it meets this definition. It's a positive counting number starting at 0. So it's natural, it's whole, it's an integer as well, and it's a rational number. So it's all of those things. If it meets natural, it meets all of them. If it meets the definition of a whole, then it's whole, integer, rational. If it meets the definition of integer, then it's also a rational number. All right, let's see about number 3, 0. All right, we'll start off with our most restrictive, natural. Is it a positive counting number starting at 1? No, it's 0. All right, so is it a whole number? Positive counting number starting at 0? Yes. So it's whole. If it meets whole, it meets the rest of them. So that means it's also an integer, and it's also rational in that order, right? Integers are no decimals, so they can be negative, positive, or 0, so it meets that definition. And all of these numbers we already said were rational. All right, let's try the next one. Negative 19. All right, let's start off with natural. Is it a positive counting number starting at 1? No, it's not. So then we'll go to whole. Is it a positive counting number starting at 0? Nope, it's not positive, right? So let's go to the next one. Integer. No decimals, but it can be positive, negative, or 0. So negative 19 isn't a decimal, and it can be negative, so it looks like it meets the definition of an integer. If it meets the definition of an integer, it also meets the next definition of a rational. Remember, if you're natural, you're all 4. If you're whole, you're these 3. And if you're an integer, then you're also integer and rational. All right, let's try the next one. Now, remember, I'm going to simplify this in my calculator so I can better understand it. This is going to be a negative square root of 100, which means negative 10. So now I can look at it better and classify. All right. Is it a natural number, which is a positive counting number starting at 1? Nope, it's negative. Is it a whole number? Positive counting number starting at 0? Nope, it's negative. Is it an integer? Well, it's not a decimal, and it's negative, so yeah, it meets the definition of integer. If something is an integer, it's also rational. All right. Number 6, 3 over 7. Okay. Is 3 over 7 a positive counting number? No, it's a fraction, right? I don't count with 3 over 7. All right. Is it a positive counting number starting at 0? No, we said it's not a counting number. All right. Integers means no decimals. Well, if I put 3 over 7 into the calculator, it's going to give me a decimal. So this can't work. So that means the only definition that this meets is a rational number. That's it. It doesn't meet any of the other definitions. It's only a rational number. All right, so that means the same with number 7, right? It's a fraction, so it cannot be a natural whole or integer. Those are all complete numbers and not decimals. So number 7 also only meets the definition of rational. Again, same with 8. It has a fraction into it, so it doesn't meet any of these other 3 definitions. So the only definition it does meet is rational. It's only rational. And I'll go ahead and add that word, rational only. That way we know it doesn't meet any of the other definitions. Rational only. All right. Number 9. Number 9 is a decimal that repeats, right? So it's rational, but since it's a decimal, it doesn't meet the definition of these 3 other classifications. So this is also rational only. All right, number 10, let's figure out what this number is going to be. It has to be a perfect square radical, right? Or else it would have been in our irrational bubble. So the square root of 121 is 11. All right. Now this is not a decimal, so it must meet some definition, right? Is it a natural number? Is it positive? Yes. And is it a counting number, meaning it has no decimals? Yeah. So this is a natural number. We know that if it's a natural number, it meets every single other definition. So let's go ahead and add every other category. It's also a whole number, it's also an integer, and it's also a rational number. All right. So go ahead and pause the video and make sure you get all of those definitions down. Okay? I'm going to move to the next page. So this is my last page. We're talking about sums and products of rational and irrational numbers. So we're trying to figure out if there's any sort of rules that we can assume when we're trying to find sums and products of rational and irrational numbers. So before we start, let's do a quick review. Sum means the answer to an addition problem. Product means the answer to a multiplication problem. All right, now that we got that, let's give a brief overview of rational and irrational. Remember, rational numbers can be written as a fraction. That's the definition, can be written as a fraction. And irrational numbers are decimals that do not end or repeat, And another example of irrational are non-perfect square radicals. All right, so we defined everything up top. Sum means the answer to an addition problem. Product means answer to a multiplication problem. Rational numbers can be written as fractions, and irrational numbers are decimals that don't end or repeat, and non-perfect square radicals. Okay? So when we're adding a rational plus a rational number, the sum will always be rational. I'm going to always be rational. Yeah, that's fine. Same with the product. Rational times rational will always be rational. So if you take, okay, so we know that the sum, rational plus rational, will always be rational, and the product will always be rational as well. So take, for example, 2 plus 3. 2 is a rational number, and so is 3. When I add them together, I get 5. Man, I gotta practice not like leaning into the webcam. All right, so 2 plus 3 is 5. 5 is also a rational number. Sorry, I'm doing too many things at once. Okay, sorry about that. You have my whole attention now. So if you're adding two rational numbers, the product will always be rational. Same with the sum will always be rational. Same with multiplying. If you're multiplying 2 times 3, that gives you 6. 6 is also a rational number. So any different combination that you want to make of adding two rational numbers, their sum will always be rational. Any two products that you want to do will always be rational as well. So if you've got two rational numbers, the answer is going to be rational. All right, well, what if I have a combination of rational and irrational numbers? So let's think about the sum. The sum of a rational number and an irrational number will always give you an irrational number. All right. So an example, if I have a rational number of 2 plus an irrational number of square root of 10, well, two plus square root of 10 is going to give me a crazy decimal that goes on forever and doesn't repeat, because square root of 10 is irrational. So 2 plus square root of 10, 5.162277, on and on and on. So when you're adding a rational and an irrational number, your sum is going to be irrational. All right, what about multiplying? If you're multiplying a rational number times an irrational number, your product will always be irrational, except when the rational number is 0. And I'll show you what I mean. All right, so if I do a rational number, so if I did 2 times square root of 10, 2 times square root of 10, and I can rewrite that as just with the 2 in front of it. So if I do 2 times square root of 10, again, that gives me a crazy decimal that goes on forever and doesn't repeat. So that's going to be 6.3245 ... So when you're multiplying our rational times an irrational, it's always going to be irrational. Now our exception was when the rational number was 0, so let's try that. Instead of 2 being our rational number, let's try 0 being our rational number. Well, 0 times square root of 10 gives me 0. And 0 is rational. So if you multiply anything times 0, it's going to give you 0. So that's why we have this one exception. There's one exception. When the rational number is 0, your product is going to be rational. All right, so our conclusions from this page. The sum of two rational numbers will always be rational. The product of rational numbers is always rational. The sum of a rational and irrational will always be, let me move my face. Get that out of here. Will always be irrational. And the product of a rational and irrational number is always irrational as well, except we have one exception. Except when that rational number that we're multiplying is 0. All right, great work, you guys. Have a wonderful weekend. I'll see you next week.